Okay, hi everyone. Welcome to the webinar. Thank you very much for joining us today. My name is Dan Shannick. I'm Director of Research at the Institute for Catastrophic Loss Reduction. I'm hosting today with my colleagues Eric Sparling from the Climate Risk Institute and Katarina Watson and Ben Hodick from GIZ, together with the Ontario First Nations Technical Services Corporation. Our organization is comprised of PIEVC Alliance. Claire Sanders of the Climate Risk Institute is today's Zoom host. If you have any audio or technical issues, please message Claire directly through the chat. Also, feel free to reach out to Claire if you have any questions about this webinar or the webinar series in general. Please note that we are recording the webinar today, and a link will be sent out to everyone who is registered, and we'll also be posting the webinar recording to the PIEVC Practitioners Network. Special welcome to those of you who are joining from outside of Canada today. Today, I am joining you from the traditional and treaty territory of the Mississaugas, specifically the Mississaugas of Scugog Island First Nation, signatories of the Gunshot Treaty of 1788 and the Williams Treaties of 1923. I welcome everyone to introduce themselves in the chat. Please tell us where you're from and add your own land acknowledgement if you'd like. And a quick note that we'll be using a couple of Zoom polls today, which should be appearing on your screen shortly. I see that some of you have been introducing yourself in the chat, so thank you very much for doing that. And we are going to move to a couple of polls. They should be visible on your screen currently. The first one concerns where you are joining from. So we'll take a minute to fill those out and see the results.
Sorry, panelists can't join, unfortunately, I don't think. So it's folks who are in the audience for this one.
Just for the audience, okay.
Okay, we're nearly there.
Great.
Okay, I'm gonna end the poll and share the results.
Great, thank you, Claire. A good mix of participants, especially from Canada as usual, but also some international participants, which is really good to see.
And early on the east, or on the west coast, so we appreciate that.
Thanks to all of you joining from the west coast of Canada very early in the morning as usual.
Okay, I'm gonna go to the next one. I think we're just gonna do one more. Oops. Sorry, hang on. Go back. And here we go. So have you used the PIEVC protocol before? Okay. Oh, we're still counting up. We've got over 100 people in here right now, so I'm just going to end the poll and share it. Share results. There we go. Can you see it, Dan?
Yep, we can see it here. So we've got quite a few people who haven't used any of the resources or services to date, which is a good thing. So we're glad that you're here to learn from some of the key practitioners in this area. And we've got quite a few people who have used the protocol itself and a few people who've used the high-level screening guide. So thanks very much for your responses. It's also really great to see such a large crowd here today. Thanks again for taking the time to join. So I think we're going to move on to the next slide. So this is the 6th webinar of an 8-webinar series focused on the PIEVC protocol. On February 9th, we're going to have another high-level screening guide focused webinar, just because we had quite a bit of interest in presenting at this forum. So this is sort of part A of the high-level screening guide focused webinar. And then on February 9th, we'll have part B, and we'll talk a bit about that at the end of the webinar. But there's several webinars that have been completed to date, and you will be able to access recordings of those via CRI's website. If you could move to the next slide. Right, and these are some of the previous webinars, which, as I mentioned, you can access by the CRI website. Next slide, please. So one additional opportunity for participants today is that you can continue the discussion that we'll have today and continue interacting with some of the great presenters that we'll have via the PIEVC Practitioners Networking Space. That's part of the PIEVC Practitioners Network. If you haven't joined it yet, I see a QR code there that you can scan. And I think Claire will put a link in the chat. So we very much welcome everybody's participation. Feel free to join. The network is completely free, and we hope to continue using that to engage with the PIEVC community. Next slide, please. If you weren't able to join us at previous webinars, we'd like to highlight once again the upcoming PIEVC Global Forum, which will be held at the Sheraton Wall Center in Vancouver on April 18th, 19th, and 20th of this year. There'll be 2 days of keynotes, panels, breakouts, working session with some city tours as well planned. Many of the themes and discussions from this webinar will carry forward to the Global Forum, and part of the intent of this webinar series was to set the context and provide some background to potential participants ahead of the Global Forum. Registration for the Global Forum will be opening this month, so keep an eye on the Practitioners Network and your inbox. And I believe Claire will also be sharing a link to the CRI webpage that will provide more detail on the Global Forum. So today our focus is the PIEVC high-level screening guide. We've got 4 excellent presentations lined up, and thanks again to our presenters for offering your time to participate. First, we're going to have a really brief introduction to the high-level screening guide itself by one of the lead authors, Jeff O'Driscoll of Associated Engineering. Next, we'll have a case study application of the high-level screening guide offered by Zane Sloan of Arcadis IBI and Sarah Gaib of the government of British Columbia, followed by another case of vulnerability assessment by Charling Lee of City of Vancouver. And our last presentation today will be by Andrew Harkness of Morrison Hershfield, and a man who needs no introduction. I think you've all seen him here many times before, Joel Nodelman of Nodelcorp Consulting, who will be talking about some of the work they've been doing for federal government assets, in this case in Gatineau, Quebec. And note that we will do our very best to hold questions, Q&A to the end of the webinar. We'll do our best also to make time for questions at the end of the webinar. If there are any critical clarification questions during the presentations, we'd invite you to enter those into the chat box or use the Q&A function. Actually use it throughout the webinar, throughout all the presentations, to record your questions, and we'll make sure that these are presented to the presenters either immediately after the presentation or more likely during the Q&A session at the end of the webinar. And of course, any questions that we can't get to today, we have a very large audience. We'll make sure that people are able to connect with the presenters. So without further delay, we're going to move on to our first presenter, who will be Jeff O'Driscoll. Jeff O'Driscoll is a civil engineer with over 30 years of experience in engineering management, project development, and planning, design and construction, and is currently the infrastructure division manager for Associated Engineers Winnipeg office. So with that, we're going to pass it over to Jeff.
Okay, well, good morning, everyone. Hopefully, maybe you can get some acknowledgement that you can see me and hear me. So I'm going to, first of all, talk to you about the high-level screening guide. I'll just give you a bit of an overview. Like I said, my name is Jeff O'Driscoll with Associated Engineering. I come to you from Winnipeg. And I acknowledge that I'm coming to you from Treaty 1 territory, the traditional territory and homeland of the Ojibwe, Cree, Oji-Cree, Dakota, Dene peoples, and the Métis Nation of Manitoba. So thank you so much. Next slide. So really what I want to talk to you about in the next 10 minutes or so is the high-level screening guide. And the high-level screening guide was developed to provide a more streamlined and rapid screening level approach to climate risk assessment. It's building upon the PIEVC products in general, But many of you, as saw by the poll, are not necessarily aware of the application. So really, I'm going to try to give you an overview, a few minutes to see that. And of course, you can go to the PIEVC.ca site, grab a copy, register, and all the products are there as well. So next slide. And I think, so when we develop these products, they're not done by just myself or others. There's a large group of people, including some of the people presenting, Joel and Joan, and a number of people on here, as well as the sponsors of these programs. So, but just to let you know, and that it was developed by a team of experienced practitioners and stakeholders. So the high-level screening guide is really an evolution of PIEVC product. And it's a very important thing. So much of what's gone into it is the experience of doing PIEVC assessments over the last, say, almost 15 years, and trying to streamline the process, provide the tips and a variety of things to make that happen. So next slide. So for those of you not necessarily overly aware of PIEVC, PIEVC is a climate risk assessment tool. It was developed by Engineers Canada originally many years ago, and now taken over by the PIEVC partnership. And it really was just a basic risk assessment based process where you looked at what were you defining, get information, do risk assessment, do engineering analysis, and move forward. As we started to use that product, what we'll call kind of the conventional or PIEVC classic or more comprehensive PIEVC, we started to, many of us practitioners started to streamline the process anyway. So a few years back, we decided, or through the partnership, they decided to maybe refresh that into a little bit more of a streamlined process, one that had more application to many users, and a little bit more streamlined instead of a very large guidance manual. So we broke it down into a very similar product, but we just sort of rebranded it in terms of understanding the scope, getting data, assessing your risk, and reporting, and then moving into some type of adaptation step. And to do that, we kind of have this roadmap in terms of things. And I'll walk you through this process of what the high-level screening guide suggests in a few things. Next slide. And I think part of understanding why it's a guide, it's not a standard, is that you can apply this to many different attributes and many aspects, depending on what frame you're coming from. So in the Canadian context, the federal government and many of the provinces and many municipalities are dealing with what they call a climate lens. So, with projects requiring funding and a requirement, a resilient assessment is required as part of that process. And the high-level screening guide is a great tool to do that. We really looked at that process and really built the tool to work with that almost, completely, but also the other aspects. It's a really good tool to support the First Nations Infrastructure Resilience Toolkit, which is in evolution as well. And asset management, a lot of municipalities are really either refreshing, doing a more asset management plan or creating plans. And a good climate risk assessment process as a layer in that asset management plan is very key. And the high-level screening guide is great for that. As a designer, using it in a preliminary design process for climate consideration is a really important tool, as well as we move into more and more necessity to work at natural infrastructure. This is a great way to look at it. And we've expanded it from a very infrastructure-centric view, as well as, just applications in general, maybe on the international scene, where this can be used in the spirit of ISO 31000 and 14090. Next slide. So I'm just going to walk you through some of the steps, as well as some of the pieces. So really, step one is really where you're looking at understanding the objective of your assessment, the scope. In this case, for the graphic, it's like for a climate lens application. So kind of what products, what inputs, what timeframes are there. But within also the context is the work plan. If you see in this graphic on the left, the step one where we have scope, criteria, context, and criteria, that aligns well with the ISO processes and language. It also, what we've bundled in terms of things is an idea of what type of team would be required to do these kind of things and where that emphasis is. So next slide. So some of the things that the product does is not only has the process, but will help you to decide on what kind of team you need to put together to do an assessment, what sort of technical needs, administration needs, stakeholder input in terms of that. So there's guidance in terms of how to build your assessment team. Smaller assessments might require smaller teams. Larger assessments might require larger teams and more specialty. Depending on the rigor you want, you might want to have professional engineers assigned. It depends on your application. Next slide. It also gives you some idea of how to scope this assessment in a simple context. Now this, we gave some overall direction of scope, general timeframes, and team. So, maybe a municipality or somebody might want to develop a work plan or an RFP based on this to understand how this will fit into their process in terms of how many timeframes or things. Now, this is for a very simple assessment. More complicated assessments probably require larger timeframes, more rigor in terms of project management. Next slide. When we get into the next step, and this is where we start to, we've already defined the project scope, probably some of the geography, some of the timelines. We're starting to get into the understanding of the actual elements. And we used to call it infrastructure, but we call it elements because really what we're looking at is as a wider view. So this is where we define what we're looking at in terms of either infrastructure, natural environment, people. We define the boundaries. And in many cases, this is where we go and see the infrastructure, some site visits. We also in the box, probably we bold out or highlight probably who will lead this phase of the assessment. And this is probably more the technical side. Next slide. There's also, some guidance as you develop your elements or your asset lists, just some ideas that there are, are you looking at single asset portfolio or larger portfolios of work? And the high-level screening guide can definitely look at both applications and more simple applications of portfolios. Those are relative larger groups, maybe similar infrastructure or categories as well. When you get into very large, complex portfolios, you probably start to need to look at other products to enhance that. But the high-level screening guide is embedded into those processes as well. Next slide. And like I said, when we look at asset categories as part of these elements, we really look at the traditional way PIEVC uses a lot of the bricks and mortar types of things, roads and bridges and culverts and buildings. But we also more and more, we're really needed to adapt to climate changes, to look at the natural environment, as well as the interaction of people, employees, stakeholders, users of these facilities in a larger sense. Next slide. And there's more and more guidance in terms of actual attributes, elements, sub-elements, and stuff in the tool for you as well. Next slide. So once we've kind of have the idea of elements, at the same time, and not as a next step, is starting to look at climate and really to feature, your climate. What are you looking at, given that this is a climate risk assessment process, developing those parameters, hazard, and indicators. And this is where you're going to establish what kind of climate scenario you're looking at into the future. More climate change effects or less climate change effects. How far into the future are you looking? How do you establish overall thresholds? And ultimately, the end of the process is to establish likelihood scores for those climate elements. Next. And we provide a host of resources to get that information, and that's current. If you're not in the Canadian context, you can definitely move forward into some other pieces and otherwise. Next slide. One of the innovations in the high-level screening guide is at least one simplified approach to assign likelihood scores to a lot of the climate information. Over many years and working with many climate scientists, we came up with some general tendencies of ourselves of a framework. How do we turn that climate projection and data into scoring that we can use in the next phase of risk assessment? So we came up with this approach, or a simplified approach, where we can, in some cases for a method, really be founded around the idea of the current climate being in the middle, and there's going to be more or less climate change in the future, or more of that event or less of that event. It's a very qualitative approach, but also there's also other rationale to establish that have more quantifiable or other means. So the simplified method is there, and we'll call that the baseline approach, and it can kind of work very easily. So I would suggest something, a lot of our current climate might be in the middle. Now, working on this for a few examples, things like extreme rainfall might actually start higher because some of the shifts from the existing data have already moved forward. So that's just a general idea. Next slide. And within that, we love to the tool helps you to document all of this information and to create reports, and we give some sample reports. Next slide. Once we have all that together, the heart of the PIEVC process is really how do we interact between those elements and those climate parameters to come up with consequence and likelihood to come up with a risk score. And based on that risk score, we can move forward into understanding. So really that's the key. In a lot of cases in PIEVC, next slide, it's done through the use of a worksheet where we put together all of the information developed in the previous steps. And this is where we kind of interact, we go through, we establish overall the consequence. The risk assessment piece is really the risk identification is very much through a discussion on consequence. If this happens, how bad is it? The climate data and climate projections provide you the likelihood, and that's where you come together. So next slide. So once you bring all that together, usually done in a workshop or can be done in a workshop form for large or done in groups or done individually and circulated, move that. Then we get into this idea of summarizing the risk into high, medium, and low risks. And then based on those high, medium, low risks, we start to look at actions. So obviously, that's very important. Other frameworks may have different scales in terms of high, medium, high, and other risks. And you're welcome to move that on in terms of some of your risk thresholds as well. Next slide. And then finally, at least in the process, is the reporting. This is where you do the final risk analysis, document the work that you're doing, and then move into other stuff related to reporting. Next slide. And this is really about finalizing the steps of the study. So in a climate lens assessment, this is where you would look at actions and adaptive actions related to medium and higher risk items as well. A few things. This is kind of, step 3, the first steps are identifying the risks. And this is step 4 is about the risk treatment and next steps. Next slide. And then just overall reporting, and this can be verbal reporting. It can move into next phases of work. It can be done internally, next things. And one final slide after this, Dan. So, and then really moving on to next steps of adaptation. So really within the confines of your process, it isn't necessarily an adaptation plan, but it's a step before adaptation planning. So there's a variety of frameworks to move that forward. So that's kind of a little high level overview of the tool. And you'll gain more of this as you see some of the next presenters sort of talk about the application. So thanks, Dan.
Thank you very much, Jeff, and sorry for the limited time allotment. There's a lot to cover here, yeah. But excellent overview. We do have a couple of questions about methods here, but I think these can be saved for the general panel discussion. I think many of our panelists will have some thoughts on these. So we'll leave it there. And thanks again, Jeff, for your inputs. And we'll have some more time to talk with Jeff at the end of the webinar.
Thank you.
So next, we're going to move on to Zane, Sloan, and Sarah Gaib. Zane Sloan is a civil engineer with Arcadis IBI Group. Most of his career has been focused on road infrastructure planning, design, and construction. In 2014, Zane began refocusing his career toward the challenges of adaptation to climate change. Sarah is a geotechnical engineer with the BC Ministry of Transportation and Infrastructure. Most of her career has been focused on geotechnical work associated with road infrastructure, including foundations, slope stability, and landslide design. Sarah's current role is engineering director for the Cariboo Road Recovery Projects. So thank you very much, Zane and Sarah, and we'll pass it over to you.
All right, I have too many slides, so I'm going to go pretty fast. So next slide. Just wanted to show you the heart of the machine here in British Columbia. And in a heart, there's 4 chambers, and what we see here on the right side are 4 cells here. Basically, PIEVC came up with the protocol, right, back in 2000, started in 2005, but I'm starting the story around 2006, about 17 years ago. That's when the ministry really started getting engaged in this realm. And by 2010 to 2014, that first box you see in the flow chart, that's when they undertook the PIEVC protocols. Then the second part of the chamber, they got the best practices guidance. And then the next part of the chamber, they got the technical circular, the technical standards and policies established. And then, knowing the high risk items that we have here in province, that's when we're getting to more detailed climate risk assessments. And that's that bottom part of the flow chart. Next slide, please. Just wanted to point out how this aligns with the flow chart from the climate lens from Infrastructure Canada. First step, get your vulnerabilities figured out. And then you figure out your medium and high risk items, you get into detailed climate risk assessments. And of course, the end product is here to select and implement relevant resilience measures. And that's where we're all headed. Next slide, please. So this is just to show the 5 PIEVC protocol assessments that the province undertook between 2010 to 2014 and encompasses a range of climatological conditions in British Columbia. Next slide, please. Out of, they grouped infrastructure into many categories, almost 100 or so, but in the end, they realized, they came to the conclusion that there are 14 categories at high risk in the province, and 5 climate hazard events are largely responsible for these high risk things happening. Next slide, please. Of course, once they figured out what was high risk, that's when they developed these best practices. Next slide, please. This is the policy, the technical circular, and that was important basically to tell engineers, if you design infrastructure for the province, you got to take climate change into account. Next slide, please. Now, 2020, 2021, we get a bunch of landslides in the middle of the province. This is the Cariboo Road Recovery Project. Next slide, please. It's located here in the province in the middle, right in between all of those other PIEVC protocols that were done previously. Next slide, please. But then, of course, as everyone is aware, that the November flood disaster happened here. And I'll even read off some of the things that were discovered that were at high risk, such as, and you can see them all destroyed here, embankment cuts, hillsides, debris torrents, structures that cross streams, that's your bridges, river training works, pretty much anything in the water, culverts, asphalt spillways, in-stream habitat works, off-channel habitat works, and of course, what was the culprit? Precipitation events, extreme hazard events, and that's what was theorized during the PIEVC protocols and now confirmed here as the disasters really started to hit British Columbia. Next slide, please. Enter stage left, the PIEVC high-level screening guide. So this came out in February 2022, and we realized we can undertake this, use this tool for a detailed climate risk assessment, looking more closely at these 14 categories at high risk. Next slide, please. So what do? We take that PIEVC high-level screening guide spreadsheet, we pre-populated it with these 5 climate hazards and these elements that we know that are already at high risk. And we want to give this pre-populated spreadsheet to the design team so that they can start to populate it with the actual infrastructure they're currently designing that fall under these categories that are at high risk. And I got a gold bar on the right side where I say, this is the gold. This is really what we're after here. We want to have these conversations with the design team about these high risk elements, considering these climate hazard events to figure out, is there still anything at high risk in their design as they're currently designing it? Next slide, please. So this is the first project we undertook. It was for the Kearsley-Dale Landing Road project. And what you see here is the alignment of the road alongside the Fraser River. We can see in this air photo the difference between forested areas and where the drainage arrows go. Those polygons are the drainage catchments that we needed to consider along the way. Next slide, please. We also, of course, had the design plans to go along with it, profiles, cross sections, and planned use. Next slide, please. This is what the end product, after we undertook workshops with design teams, this is what it looks like from a distance, right? And what did it pull out? What did it identify? It identified what's at low risk, medium risk, and where there is still anything at high risk. Next slide, please. Now, how did we come to this conclusion? Well, we looked at those 5 climate events, such as maximum 1-day precipitation, maximum 5-day precipitation, the river flows, then the snowmelt. But we added 3 more, and we called them affected slopes. This was to take into consideration for compounding and sequential events, such as scorched earth or mountain pine beetle or land use changes, logging roads, rain on snowmelt events, and things like that to expand our consideration of risks. Next slide, please. All right, and of course we had to assign our likelihood scores, and that's what Jeff alluded to in his presentation there, talking about the middle baseline method. And what we were looking for here was the trend. So I was working with Jeff O'Driscoll on this actually, and he and I went to climatedata.ca, took a look at the trends for these, maximum 1-day precipitation, maximum 5-day precipitation, and we saw the trends going up. We had a meeting with Pacific Climate Impact Consortium to get a better idea too of climate trends in this area. And we didn't have, so we assigned our likelihood scores typically 3, 4, 5, middle baseline method, using a 3 for present day, 4 for the 2050s, and 5 for the 2080s, because that's where the trend was going. We did not have data when it came to river flows. So we assumed, well, we're looking for risks. So let's assume that that is also increasing, the trend is going up. So you can see we indicate that as a dash for the present day, then a plus for the 2050s, and a plus for the 2080s, indicating an upward trend. And that was our assumption, trying to uncover the actual risks. Next slide, please. This is from the Kearsley-Dale Landing Road project. Out of those 14 categories at high risk that were identified during the protocols, this project only actually had 5 of the categories at high risk in their project. So that's the embankment cuts and constructed and existing, hillsides existing. Then we got our culverts there, less than 3 meters. We had a number of culverts to consider. Emergency responses, and of course the road subbase we considered as well. Next slide, please. So that was where we got together in a workshop using a bit of a middle baseline method approach as well to assign the consequence scores. And really this was the whole thing. The whole workshop really just focused on these consequence scores, and of course the discussion that went along with it, which we recorded with a diligent scribe who was recording the consequences and the discussions along the way. Next slide, please. Here's what we found. I'm circling here from our spreadsheet what came out as a high risk element that still existed. Here you can see the cross section on the left side there where we got a 2.85 to 1 cut slope, which is a pretty flat cut slope. But we're talking about an area here that has now experienced a lot of interesting precipitation events after long drought events, and the ground turned a bit to mush, and we have problems here. And we came to realize that the analysis here could be deeper. Let's go to the next slide, actually. And this was the discussion we recorded that really got, and we recorded all this conversation and even had some design considerations and actions for the designers to consider. And that's where all this was recorded in the spreadsheet there. It's all documented, one-stop shopping. So the designers can then see what we considered in this workshop, and also maybe some suggestions to work on along the way. Next slide, please. And with that, I'm kind of out of time. I'm going to pass this over to Sarah Gaib. So what's happening now is we've handed this spreadsheet off to the designers for them to consider. Now the project has taken some twisted and turns since then, but that's where we're headed now, is to actually compensate and mitigate those risks that we identified during the workshops. So over to Sarah to talk about what we're doing next.
Thanks, Zane. And so I'm just going to speak to the assessment that was done and any gaps or opportunities for improvement that we feel can be applied to the assessment. So next slide, please. Yeah, so just looking at those 5 hazard parameters, and as well as the elements at risks, I think Jeff had called those the asset categories. So there's 5 and 14 of them. Just looking specifically at the Cariboo site, there needs to be consideration for additional parameters there. So in the case of the Cariboo, we saw that there was a lot of movement associated with a long duration of rain, and that's not reflected in the parameters that just those 5 that have been highlighted. And similarly, looking at the elements at risk, they need to be specific to the site. So just an evaluation, I think Zane ran through that of the 14 that have been shortlisted, 5 applied to this one. And we have examples of other projects where 14 may not be comprehensive enough and we need to add to it. So just really looking at the site specific needs and whether those parameters are sufficient. Similarly, just looking at the risk assessment itself, we want something that's going to be very repeatable and transparent and can be applied much more broadly. And each practitioner who does the work, it's done in a very consistent manner. So looking at the work that was done, the consequence, it's very, I guess, vague. It has limited guidance in terms of what that means. And from one project team to the next, the interpretation of that may be different. So the ministry has, different examples of how we've done this for other prioritization work, such as our rockfall hazard rating system or how we do seismic retrofit. And so what we tend to look at is consideration for the road classification, whether it's a primary highway or a low volume road. We consider the operational impact, if it's a couple hours to clean up material, if it's, a closure that's days, weeks, months. When we had the November atmospheric river events, we saw that the closure of 1 month on the Coquihalla was pretty catastrophic. And then consideration if the road itself is just a single access to a community, and that if it is closed, it would be cut off. So the ministry is working through further defining what those different scoring levels will mean, from a very low impact to a very high. Next slide, please. And similarly, both Zane and Jeff have talked about the probability. So we're looking at the trend, is it getting wetter? Is it getting hotter? The approach that was taken here for the Kearsley-Dale, so I've copied over the Kearsley-Dale numbers, and just looking in that first column, the 1-day rainfall went from 23 mils to 25 to 29. And Zane's correct, the trend, it continues to go up. And so it was scored 3, 4, 5. And that's very conservative. Jeff had what he had shown in his slide was looking at a percentage increase. And his slide spoke to, 50%, 100%. So the ministry is looking at putting bounds on what those scoring guidelines would be. And so that will just help as well for consistency on that end. And that's it for my presentation.
Excellent. Thank you very much, Sarah and Zane. Excellent presentation. And we have a few questions that I think, once again, will actually, many of the questions are related to scoring methods here, but we'll save those to the end for the panelists. Thank you again, Sarah and Zane. And we are going to move on to, Charling Lee. So Charling Lee is a green building engineer in the sustainability group at the City of Vancouver, situated on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. Charling has 15 years of experience in engineering, planning, and research roles in sustainable urban development and energy transition. And with that, we'll pass it to Charling Lee.
Great, thanks. Hi, everybody. Good morning. Next slide, please. Hi, so yes, my name is Charling Lee, and I'll start with a land acknowledgement. Again, I just wanted to acknowledge that the City of Vancouver is on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. This map here is from nativeland.ca, and it has the settlers' name turned off, but you can see that City of Vancouver is that peninsula kind of in the center of the map. The Indigenous names in gray lines show the various overlapping territories for the First Nations that have lived on these lands since millennia. And I really wanted to take a minute to honor, acknowledge the First Nation stewardship and care of these lands, and especially as we continue this discussion on climate risk and resilience, and while we're deepening our relationship with the land and the environment that sustains us, and as we're trying to move towards climate justice in our work. Next slide, please. So I'll just give some context for resilience in the city of Vancouver. In 2012, our council approved our first climate change adaptation strategy and updated in 2018. There are efforts from various groups within the city to address the different action areas, such as climate robust infrastructure, healthy and adaptive green space, community preparedness, coastal preparedness. The action area that I work in as part of this strategy is the priority for future-proof climate resilient building stock. So I'll focus on the building tools that on the policy tools that I'm working with in order to advance this priority, the Vancouver Building Bylaw and our rezoning policy. So last May, our council approved changes to our building bylaw to address the most pressing health and safety hazards for Vancouver, which are poor air quality from more wildfires and extreme heat. So the air filtration requirement addresses the first issue, while cooling in multifamily residential buildings addresses the second issue. And the second tool that we have at our disposal is our rezoning policy, which applies when projects are seeking additional densities than what current zoning allows. So since 2018, we've asked large developments to answer questions about the resilience of their project. Taking what we learned from these projects and summaries, we're setting up more structure for carrying out resilience assessments, and we're leaning on existing frameworks like the PIEVC high-level screening guide and BC's hazard risk and vulnerability analysis tool in creating this worksheet. Next slide, please. And I'll give you a little bit more context about the policy requirement for resilience assessment. So this is tied to a rezoning application. So this is very early days in schematic design of a building project. The majority of projects that are being, floor area that's being rezoned in the city of Vancouver is residential. And feedback tells us that resilience conversations in this sector particularly are not really being advanced. So as we're working on the next iteration of the resilience requirement, we want to address this issue by setting up the framework and the minimum expectations for what the resilience conversation should look like. We're creating a process based on the PIEVC high-level screening guide and a reporting format. And I'll just acknowledge that many BC public sector buildings have higher resilience assessments or design standards even. So this tool isn't really aimed at those projects. Those projects can just carry out their specific resilience assessments and provide us the report. They wouldn't have to step through our process. Next slide, please. Great. So what we've done as part of our assessment framework is we've set for industry what the building site and occupant scope is. We've got recommendations specific to the building industry around what the assessment team should look like. It should include all the design disciplines, the owners, and representatives of the building users and operators. We're recommending a format, a workshop format. We're highlighting this as a qualitative assessment, and it really is a starting point for design teams to talk about risk and resilience. Next slide, please. And the goals of this assessment, like I mentioned, is really to add structure to consider resilience during current building design processes. So this requirement is for large new buildings. We're setting minimum expectations for assessments that are suited to the building scale and what can be known at the early design stage. Through projects having to meet this requirement, we're hoping that it raises awareness of climate risks changing over the building's life. We're still hearing a lot of feedback from industry where, conversations about what happens to the building during operation and near the end of life isn't really being had because of the nature of the market itself. And we're hoping that these assessments will help us evolve best practice for climate adaptation and most importantly, identify the barriers that projects are facing to give us, the City of Vancouver, feedback for any future policy code changes that we need to incorporate. Next slide, please. So I think most of you will be familiar with this definition of risk. I think it's adapted from high-level protocol. Our 4 steps that I'll go through in detail are an exposure screen, identifying the impacts, identifying the likelihood and risk, and identifying the resilience strategies that are applicable to the project. Next slide, please. So step 1, what we're asking projects to do is to decide on a qualitative level whether the project has no exposure, low, medium, or high exposure to the hazards. And we've given a framework for what the hazards are specific to the Vancouver context. And we're asking that all medium or high exposure hazards be moved on to the next steps. Next slide, please. And as a second step of identifying the impacts of the category, we are providing a list, a basic list of suggested impacted systems and elements that are applicable to the building scale. And we're encouraging teams to use this as a baseline, but of course add to it as they see fit. We're asking them to take a qualitative assessment of the consequences from a 1 to 5 scale. And at this step, we're asking them not to consider likelihood in this step because that'll be coming up in the next step. Please, next slide, thank you. And then in this step, we're using the qualitative likelihood scale from the PIEVC high-level screening guide to evaluate how the hazard will change over the life of the building. We're asking projects teams to use internationally recognized climate projections and conservative scenarios. And like many of you are aware, that will give you a risk rating. Next slide, please. And finally, the last step in our process is we're asking that all projects with all the medium and high risks identified in the projects to identify what the possible strategies are to mitigate those risks. We want them to tell us which strategies will be included in the design, which strategies will be explored for future adoption, something that maybe they can address through the design process, through the design of the building, that maybe it's something that can only be considered in construction or operation of the building. We want the teams to tell us how or when will the information be passed along and who may be responsible for the strategy. And for strategies that are applicable to the project but are not being implemented now or considered for future, tell us why not. What are the barriers that exist? You know, in order to give us feedback and help the industry figure out what are some of the really applicable strategies to the building stock, and why can't we do them? Last step. Last slide, thank you. So as I mentioned, we're working on a resilience worksheet that's currently in process. What that really looks like is an Excel tool with 4 or 5 tabs, very similar to the high-level screening guide, different color schemes, and a page for reporting all of the high risks and high medium risk and the strategies that are applicable and what's being done and what's not being done. And I want to highlight here that there are a number of resources out there already for the building context and for the BC building context. We know what the resilience strategies are. The gap that we see and what we're trying to address is the understanding of the hazards, how they apply to your specific project, and how the hazards change over time, and prioritizing the risks. And so this is one of our tools to really move the conversation forward to adopt the strategies that work for the project and help us move code and policy along. And that is it for me. Thank you. Oh, and there's my information. I can't stick around for the panel discussion, unfortunately, but please email me with any questions as you need to. Thank you.
Great, thank you. Thank you very much, Charling. And we understand that you can't stick around for the panel. Yeah. So you've got your contact information here. Thank you again, Charling, for the case. I think we'll try and stay in touch with you and learn more about your work as this develops. And of course, we're all interested in building adaptation in Canada, and often look to BC as a great example of how to move forward. So thanks again for your time.
Thank you, everyone. Have a great day.
Bye. Okay, and moving along. Next, we have Andrew Harkness and Joel Nodelman. So Andrew is a principal of the firm, Morrison Hershfield, vice president and climate change practice lead at Morrison Hershfield. He's got over 30 years of infrastructure planning and design experience and is a project management professional. And joining Andrew is Joel Nodelman, who many of you know. Joel Nodelman is an engineering and risk management specialist with over 40 years of professional practice. He's been involved in the PIEVC program since the very beginning and has provided his expertise for many PIEVC products and resources, including the high-level screening guide. And you may have seen him present last time as well. So with that, we'll pass it over to Andrew and Joel.
Well, good morning, everyone. Nice to be with you all today. And thank you for the invitation to be with you to be able to present on our climate risk and vulnerability assessment work that we recently completed for Brookfield Global Integrated Solutions, or BGIS, on behalf of Public Works and Government Services Canada. At our client's request, we're keeping the presentation at a relatively high level, but we're happy to share an overview of the project, the process we followed, as well as some of the key outcomes and lessons learned. Our introductions have been given already by Dan, so I think we can move on to the next slide. Just an overview of our presentation. I'll lead off with just a little overview of the assignment, two actually, that we undertook for BGIS, and then we'll hand over to Joel, who will walk us through the scope definition, data gathering, and risk assessment steps of the risk assessment process. And then I'll wrap up with some of the findings, key outcomes, and lessons learned. Next slide, please. So just an overview of the project. Morrison Hershfield with Nodelcorp assessed multiple existing federal government building projects and sites following an approach consistent with Infrastructure Canada's Climate Lens guidance, ISO 31000 risk management standard, and following the PIEVC protocol high-level screening guide. A total of 9 sites were assessed, all in the National Capital Region. Typical building uses included office space, some retail. One included museum storage. Some of the space was rented out to other users for education purposes, and there were some other uses as well. So quite an interesting mix of uses of the building sites. They've all been around for quite some time. Typical adjacent land uses mostly were in urban context, but 2 of them were in or near to a large forested green space on the Gatineau side of the National Capital Region. Next slide, please. At this point, I'll turn it over to Joel. Just need to unmute.
Yeah, I'm trying to find my unmute button.
Very good.
Okay, so I'm going to very quickly go through the steps we followed. Now, these are basically, all of this work followed the high-level screening guide. So I'm not going to go into detail on each step in the way that Jeff would have, but I'm more interested in how we applied all of that to this portfolio of buildings and how the team structured the work to get consistent results. So we did follow the high-level screening guide. We were concerned about common features across the whole portfolio, so we considered that in the way we defined the scope. We defined a standard set of climate and infrastructure parameters that we worked with as a starting point. And as we went into each specific assessment, we would tweak that to be more representative of the specific site. But it started with a consistent, almost like a standard set that we would work with, much like the work that we're talking about in BC. It's a standard set we start, and then we kind of tweak it out based on the site. So we defined the scope that way that the client actually defined the buildings we're going to be looking at. And then a lot of our discussion in the scoping stage was how far out do we take this in terms of interactions with third parties, with people who are accessing the site, with neighbors, those sorts of things. So that was considered in the work that we were doing. We went to gather data. I think the important thing about this and the tweak that we made is that there was a site visit for each piece of the work. And also we drew data from recognized sources. So for the climate data, we drew from the Climate Atlas, climatedata.ca, but it was then filtered through the the technical team at Morrison Hershfield to make sure that the data was robust and adequate for the purpose of each assessment. So we would draw from and then adjust the data as appropriate. As it was a portfolio, we were trying to keep the climate parameters relatively consistent across the board so that we could have cross comparison between all of the buildings that we were looking at. But some of those core parameters needed to be adjusted just a little bit as we went along. We included in, for example, in climate, invasive species, which not really a climate parameter, but we did consider that, and then we adjusted that because urban environments have different aspects of that than, say, some of the things that were in a more rural setting. So because we were doing this as a portfolio, we were very conscious that we needed to strive for consistency. So there was a lot of work in trying to keep things relatively consistent. So I'm on step 2, gather data. Sorry, I didn't tell you that. There we go. And next one, please. Okay. With the building data, we define once again a clear set of standard building elements that we would take a look at. But once again, each set of elements was adjusted to match the nuances of each building. So standard set, tweaked, and then we were able to get some consistency across the board. In this part of the work, the key thing was that the site visits. Each site was visited by the technical team from Morrison Hershfield. Extensive sets of photographs were taken, and we also developed a guide that the site visitors would take with them. So it was like a checklist. Here are the questions you need to ask. Here are the things you need to look at, so that when we got into the actual risk assessment, we had a bunch of data that we needed to look at. So we could always look at a picture of something. We could always look at the checklist to see what answers to the questions were, and that really informed our ability to streamline the actual risk assessment process. Next slide, please. Yes, so the risk assessment followed our standard approach, exposure times likelihood times consequence. We did a workshop for each site. The attendees of the workshop included the technical team from Morrison Hershfield, who did the site visits, as well as us folks from Nodelcorp in terms of risk analysis, and also representatives from the client in terms of their management, and most importantly, people who were actually working the buildings. So they're the people who managed the buildings directly, who did maintenance on the buildings directly. So that was the assessment team. All of this was done via web-based meetings. And we really found that the site visits and the attendance from the client at these meetings really informed and helped us get to some robust results. We did use the middle baseline approach of the high-level screening guide. We did have to tweak that a couple of times because one of the nuances of that approach is that for special cases like extreme events, we were finding it was tending to overstate the risk. So it was tending to drive to action on, say, a tornado event, which may occur very, very, very infrequently. So we did tweak those specific parameters on a case-by-case basis to be a more traditional 5-point scale based on the old PIEVC approach. And the results from the workshop were then compiled. We used the standard high-level screening guide and climate lens parameters to define what is a high-level, high-risk, medium risk, low risk. And so we did that, and that was, I think, the important part of this project for me was that this is typically where a PIEVC assessment would leave off. But I think what Andrew is about to take over from and explain is what we did as a project next, because I think the adaptation measures, the risk treatments are a very important part of this work. We always do climate assessment for a purpose, and the purpose is to get to the risk treatment. What are the actions we need to take? And with that, I'm going to turn it back to just one more slide. I have to talk about reporting. It's just basically I said this. We have to consider the findings from each step. What I think an important part of the reporting was that there was a detailed peer review through the team. So the entire team, all the technical, all the risk folks, everybody reviewed the findings to make sure that they were robust from the perspective of their particular lens, so that we were coming out with a consistent set of recommendations. And I think that was an important element of this that is often not stated in our guidance. So Andrew, you can take it from here.
Very good. Thanks, Joel. So next slide, please. As Joel said, risk profiles were unique to each site, but typical risks seen throughout the project resulted from parameters such as extreme heat, increased precipitation, and for one or two sites that are in or near a forested green space, setting potential wildfire impacts. Mitigation strategies were created for each site and included upgrades, for example, to building envelope and building heating cooling systems, site management plans, and or operational policy changes. Next slide, please. So assessment mitigation recommendations included a variety of things, including responses to extreme heat, upgrades to wall insulation and windows, transition to LED lighting, upgrades to cooling plants, and in one or two cases, potential responses to wildfires, such as smoke management plans, upgrades to on-site fire prevention measures. Additional examples include upgrades to on-site drainage systems to deal with increased precipitation, development of utility power outage management plans in case extreme weather disrupted power supply, and policy-related strategies such as relaxed dress codes for workers for more comfortable working conditions in conditions of increased temperatures. Next slide, please. Just a little bit about the more about the reporting, and then we'll wrap up. We did consider various planning horizons in conjunction with the climate projections, considering the age of the building, the sort of typical life cycle of the building, what age it was at, and sort of renewal and upgrade cycle. And the strategies were based on that. Budget classifications were also established across the portfolio of projects when identifying recommendations as well, considering both capital and operating expenses varying from low to high. So for example, capital expenses at the low end, things that might fall under $100,000. So not insignificant, but that was the threshold for low, varying up to at the high level over $5 million in terms of upgrades. Operating expenses had a much tighter band. Low was under $5,000 annually, whereas high was over $25,000. And just turning to our last slide, please. So just key takeaways from our team's experience on this and other similar projects that I'd like to just leave with you for portfolio assessments, such as the work we did for BGIS. It was really beneficial to start with a pilot phase, confirm the process, the stakeholders and deliverable formats, and then replicate and scale up. I think you're hearing from everyone today that collaboration is key. For these more involved projects, very, very important to build a diverse team, engage with the facility owners and operators, ask lots of questions, dig for the historic info and insights. And just thinking more broadly as an agent of change within each of our organizations, so important to be communicating the importance and the value, i.e. the business case of considering the effects of a changing climate on infrastructure, operations, services, and people. We need to invest in expanding our organization's capabilities and expertise, continue to engage through sessions such as this with our other specialists and practitioners for input, guidance, and to share knowledge and lessons learned. And finally, just to embed a climate change focus across all that we do. Thank you very much for your time and interest today.
Great, thank you, Andrew and Joel. Thanks again for all of the presenters for their excellent overviews of ongoing work. And we're going to move in here to a panel discussion. So if you would mind, I know we lost Sarah and Charling. It's very early for them. I know some folks had to get their kids off to school and that sort of thing. So it's good that Andrew and Joel and Jeff and Zane have been able to stick around. And we have a few questions centered in some cases on some specific themes. One, I think more of a general question, which I may pose to some of the sort of, I guess, lead authors of the high-level screening guide, Jeff and Joel. So we have one, the high-level screening guide itself, the name of the product sort of indicates a higher level resource for assessment, but some of the presentations today indicate, relatively detailed assessment work. And the question is, what is there scope for an even higher level assessment tool? Or maybe you could offer comments on the flexibility of the high-level screening guide to be applied for detailed assessments as well as very high-level assessments. So maybe I'll turn it to Jeff first and then to Joel.
Yeah, I think I can start with that. Well, first of all, I think the initial idea when we were theming this up was we call it PIEVC Lite. A more streamlined version of utilizing the PIEVC process. Now, by calling it the high-level screening was largely to say that this is a first slice of risk assessment for many purposes. Now, it doesn't necessarily discuss detail. So you can drill into heavy detail, heavy analysis if you want using the tool, or very light proxy other data related to this assessment. So I think the hardest thing is that the cover of the book says high level, but I think it can be applied either way. But it was largely an attempt to streamline the process and modernize the process as well. A lot of the language, procedures, and things for the practitioners. So Joel, do you want to add on that maybe?
Sure. I think much like any of the PIEVC products, they've been designed from stage one to be flexible. So they can be used at a very high level, and they can be used in very detailed assessment. And as I've learned over the last 15, 20 years, what you mean by detail is different depending on who you're talking to. So it could be very broad or it could be very deep, but the protocol is designed to do both of those sorts of things. There are situations where you may want to go even a step higher in terms of screening, and that was the reason why the large portfolio screening guide was developed, and that will be released shortly. We're going through the final stages of the release process of that, but it goes to an even higher level in terms of how to look at. We did a portfolio of 9 buildings for BGIS. It could have been some folks in this room probably have done assessments of thousands, and you need to have something to really sort that out.
I think also, Dan, that the development of the product was the original protocol really had the requirement for engineering analysis. And this sort of, it's still optional. You can still add engineering analysis, but doesn't have to be specifically professional engineer driven tool.
Yeah.
You can be part of a lot of processes outside of having to hire an engineer in your process. There are many applications where you must have an engineer, of course. But I think, if you're doing some capital planning and within a municipality and a public works department, you could use this tool without having professional engineers assigned and a variety of things. So
I agree with that.
If I could just build on that, at Morrison Hershfield, we're working on this question and thinking about how to embed climate action on mitigation and adaptation across all our projects. And we do about 7,000 projects a year. So we can't do it at this level that we've been talking about typically on all those projects. So we have to draw out some of the thinking and the expertise. And one idea is just to, bring together some expertise in sort of a working sessions, just to get some of the insights, perhaps back that up with a bit of a quick climate profile, historic and future, just to inform that discussion. And another one is to consider just a limited number of elements related to the project and climate elements and interactions. And that way we might be able to kind of quickly get to the heart of what might be a critical issue on a given project, but still, bring in the essential elements of the process. So those are 2 thoughts.
Great, thanks. Zane, any thoughts?
Only to add that it's there's this filtration process, right? That to go through, even the climate lens describes it. Look at your vulnerabilities first from a bigger perspective to get to figure out what's really at high risk. You do that detailed that assessment and help to to narrow it down and manage what is often so many assets to consider. That's all I have to add.
Great, thank you all. And we'll move on to our next theme, which I think is the most prevalent theme in the questions, which is all about the scoring method and the middle baseline approach. There's several questions about this. So maybe we'll start first, again, with Jeff and Joel to give a background to this method, how it was developed, and maybe some of your experience that led to its inclusion in the high-level screen guide.
Yeah, I can give you, so the original PIEVC protocol had several approaches to establishing likelihood, different scales, some probabilistic, some qualitative, some otherwise objective. So there's a variety of things, but what I think suggested to happen was a lot of the, and generally PIEVC is best routed by having a climate scientist partner. They're making some of these decisions. But as we went through and kind of looked at it, there was a tendency to use sort of one generalized approach. And that generalized approach was relatively qualitative in assigning things. And as each practitioner from the last 15 years did this, they created different approaches and different ways to assign likelihood scores. We used to call them probability scores, but likelihood scores towards these things. So we came up with we kind of looked back, audited, and said, really this is, 9 times out of 10, we're kind of using this relative approach anyway. So we kind of rebranded it, sifted it out to this middle baseline approach where you kind of start in the middle and you have more or less. You can use more quantifiable scales and a few things, and you can create your own scales. It's still just guidance in a direction. But I would say when you sit down with a climate scientist, climate specialist, and go through this, it's a really powerful tool to do that. And each climate parameter can have different starting and endpoints in terms of the scale. So I think it's there. It's not meant to be just a checkbox exercise. You need some good data, good collaboration with somebody who knows climate to be able to come in here and do these things. And maybe because the group of us make it look easy, it looks easy. There is still still work behind it. So Joel? Yeah,
I was going to say something else, but I just want to feed off what you said. It looks easy. What I've always said about PIEVC around these sort of high-level screening processes is that when you write it down, the math, the equation, it's three parameters, they're simple, all of that's really easy. But what's going on underneath the surface requires a lot of expertise. So we need to be aware of that. In terms of the middle baseline approach, it is an approach that we found it was interesting because when we sat down to write this document, we started comparing how we went about things. We're in different consultancies. We don't often share that kind of thing. And when we started to talk about it, we said, well, yeah, that's what we do. We start with, is it getting better or is it going to get worse? What's it today? And that gives us some sense of what the risk is likely to look like. So we found that was consistent. I do know that there are situations where that approach is just not doesn't work for me in particular. Is special case events where it's like really rare but really bad, like tornado hitting the building. Saying that it's going to get slightly worse and then increasing the risk profile is kind of meaningless from a pure risk assessment perspective. But those items can't be neglected. They have to be included in the assessment. They're a critical piece of the assessment.
I think just the final word on that, maybe from my perspective, is that what we tried to create is I won't call it quick and dirty, but a relatively easy, accessible process with proxy data usually going to the climate data, climate atlas, climate data, and all that you could assemble well. There's also, you notice in my presentation, there's a climate report. And this is where you put your detailed climate information down, those scores, where your data was formed, your assumptions, your confidence levels, a variety of things. Yeah. So the backbone behind that is quite a bit of work and documentation of why you've selected those likelihood scores through that process. So it's not just a 5 minutes in and out exercise. There's the basis of climate science behind that.
Great, thank you both. And along this theme, there are several questions, I think more practical questions about the workshops and dealing with your subject matter experts, and if there's disagreement in scoring, how do you handle that? So I thought maybe we could ask Zane first, and then Andrew, could you walk us through, your process for assigning the scores? How did you handle disagreements? How did you select timeframes? That's something that came up. If your timeframe is long enough, your likelihood starts to approach 100%. How do you handle that? So if you wouldn't mind walking through your process in a minute or so, hitting on themes like time frame, on selection of future climate scenarios, on managing disagreement amongst your subject matter experts. We'll have Zane and then maybe Andrew.
So the process for sure was to include the right people at the table, and we were in design. So we had hydrological engineers who were designing the process. We matched that with someone from the owner for hydrotechnical engineering. For geotechnical engineering, the designer was in the process of analyzing geotech engineering. Well, we had to make sure we had a partner on the owner's side on geotechnical engineering. So we had those conversations, and we had discourse, we had disagreement, we had in-depth discussions, and that's what we wanted, right? So we could document what those considerations were from all perspectives, from multiple perspectives of general civil and hydrotechnical and environmental and all that. So we could document that discussion so that designers would be informed of what the concerns are from various perspectives. And that was a necessary step for sure to get that discourse out there. And then we boiled it down. We had to resolve a climate risk score, consequence score. And often we would defer to higher rather than lower to sort of reflect that one discipline had a concern that was maybe a strong component. It was really just to tease out that discussion and document that so designers could say, oh, that's what that person was thinking about. That's what that discipline is concerned with, so we can now address that risk. Andrew?
Sure, no, thanks for that. Just a couple things. One is that given that we're often bringing people into these sessions and this process that they're experts in their area, but they're not so familiar with the process, we found, and Joel was really helpful for us, and Joan on these BGIS projects and some other ones we've done together, just taking time to have education sessions to really explain, like what you did, Jeff, with us, sort of lay out the process. And what I was thinking about in the previous question is just really the importance of taking time to clarify what these different terms mean and make sure everyone has those definitions in their hands. So we have a good grounding as we get into the discussions, the exposure, the likelihood, the consequences. Yes, I like the idea of elevating, and Zane, I was fortunate to participate in some sessions with you and your team. That was great. And sometimes you just have to put some things in the parking lot, right? And I think, Joel, you helped us with that a few times. Just say, okay, we got to move on. We got a lot of interactions to deal with, and we'll cycle back on those ones and try to understand if there's a big difference of opinion about what's going on. Why is that? And or does everyone have a common understanding of what it is we're trying to do here? So those are my quick thoughts on the question, Dan.
Great, thank you both. And I mean, another recurring theme along these lines was managing extremes, and maybe Joel, you mentioned something about the sort of difficulty managing extremes and discussions about tornadoes and that sort of thing. Could you offer any advice to those who may be thinking about going through this process with respect to very extreme, low probability events?
Yeah, I'm going to give this kind of like a two-pronged answer. The first one is from a pure risk perspective, those sorts of events are miserably difficult to figure out because very low frequency, very high impact events are the ones that most of our clients have most difficulty getting their heads around. I mean, the loss of a structure is a catastrophe, and how can you say that's low risk? And the answer is because it may occur once in 30, 40, 50, 100, 200 years, whatever those numbers are. So they're difficult to deal with. Within these processes, they have to nonetheless be considered, because what we are seeing more and more often are events that we would have historically deemed is rare, but they're no longer rare. And so we need to contemplate those sorts of things. So the way we've done that is both in the PIEVC protocol and in the high-level screening guide, treat them as special cases. They have to be pulled off to the side, and then they have to be passed through the lens of the subject matter team in terms of what does that mean, and are we comfortable? And one of the things I always come to, are you comfortable with that assessment of risk? We always, as a team, are we comfortable with that? passing that through our risk appetite lens. Is that what we really think is important? Is that where we want it? And the reason this is important to me as a risk specialist is that if I say that that is a really high risk, then my client's going to spend a lot of money trying to fix it. And so this all comes down to matter of prioritization. Where do they spend their best buck? And tornado proofing my house is probably not the best bang for the buck. That's a bad expression for that. But so it needs to be considered. It needs to be put out on the table. It's going to score typically low, medium risk, but it still needs to be then further documented in terms of here what the considerations of the team are.
Okay, thank you very much, Joel. So we have, I guess, a couple of practical questions, which I might turn, I think, first to Zane and then to Andrew. So this is always helpful information to get out to potential users. So what are the cost impacts for following the PIEVC protocol in infrastructure risk assessment, and how can these costs be included in the budgetary period? So first, Zane, and then Andrew.
Sure, and I'll say also I'm joined here with Ian Pilkington, Chief Engineer from the BC Ministry of Transportation. So Ian, if you wanted to chime in here as well, you're welcome to, of course. So how do we address the cost impacts? Well, that's a powerful question. Certainly at the end of our high-level screening guide assessment, we pass that off to the designers for them to determine whether or not there is additional adaptation measures. So in the case of high-level Kersley-Dale project that we assessed, we saw that there was the side slopes at 2.85 to 1. Well, that we got to go back and revisit that, do some more analysis, and maybe that needs to go to 3 to 1. Well, there's a cost with that. Well, those costs are now expected to be reported in the design process, right? And we also have the ministry's technical circular, their policy document, which instructs designers that they have to use climate design criteria, this design criteria document, which then has a column in it to itemize and put in there the cost for that adaptation that they had to make. So that's where that cost lives. So Ian, is there anything else to add to that?
One thing I would add as a government entity, and Zane has mentioned our this technical circular or policy we basically have in the BC government. I think if nothing else, having that policy is now making our designers as well as our project managers think about that as a cost item even before they go into a project. I think they're starting to recognize now that these things are happening. Designers are going to start asking for potentially additional funding because they have to account for climate change. And I think it's kind of a new mindset to wrap your mind around. It's for us, it's just like, I think of it very similar to when we started doing seismic design in our structures 30 years ago or so. It was a new thing. We knew it was going to cost money. And now it's just part of a project. You're going to have to account for seismic design. I think that's what's happening here. And we're still trying to get a sense of the magnitude, but it's, if nothing else, I think people are bracing themselves or anticipating and setting aside, we're going to need extra funding, just like we need funding for Indigenous consultation and environmental items. Climate adaptation is going to be in there, and now people are kind of wrapping their head around that. So if nothing else, this kind of stuff helps that, so it's not a shock later on when we come back and say, oh, we need 10% more to account for climate change.
Andrew?
Thanks, all good points. And I would say, it can also include climate mitigation, reducing carbon emissions as part of similar types of conversations, just really starting with an understanding of what's going on, the need, the direction we're going, avoiding future shocks, being proactive. I think that all this discussion around understanding, the risk level and for those areas that are potentially higher risk, the business case around taking action versus not taking action. So there's going to be much better informed decision-making with the outputs of this process that at the end of the day is likely going to save money in many, many cases if appropriate action is taken. For those things that are maybe not so high risk, it makes a lot of sense just to sort of have this information available and integrated into normal, rehabilitation upgrade cycles. So you don't have to rush out, and you just can't possibly rush out and do everything at once. So just, do good planning as part of, certainly for existing assets in terms of maintaining and upgrading them. And for new facilities, you're equipped with some much better information about how conditions are changing and better equipped to account for these factors as part of the design, which is our responsibility to do. So those are my thoughts.
Great, thank you, Andrea. Thank you, Ian, for joining the panel as well. It's very nice to have you with us. We've got a few minutes left here in the webinar. We got some logistical things to cover near the end, but one more question since we have you here, Ian. There is a question specifically about Ontario that was posed to the group, where we're going in Ontario with respect to maybe regulation of new development. I know perhaps you're not going to speak from an Ontario perspective, but we often look to BC as one of the leaders in this area, and maybe you could offer some encouraging advice, wisdom, perspective with respect to how you see BC, your fellow departments in BC, government agencies, municipal government. Are they increasingly embracing the concept of incorporating climate change risk into infrastructure design planning, buildings, et cetera? What are your observations in general in British Columbia?
Yeah, I think we are pretty progressive here for a few reasons. Like I said, I was very fortunate. My predecessor, Dirk Nyland, the previous chief engineer, jumped right in and started doing the PIEVC exercises. And Joel and Zane mentioned that before. And I think because of that, and the fact that we've had this policy since 2015 that you must account for future climate events, at least on highway infrastructure, I think that kind of raised the profile for other groups as like buildings and things of that nature. We're also fortunate our ministry, what's the Ministry of Environment, has what's called the Climate Action Secretariat. And one of their big things is not only reduction of GHG emissions, but they do have what's called the Climate Preparedness Adaptation Strategy, which is a strategy for BC, which is us becoming more climate resilient. And I think we've been working on this for many years, but I think the last couple of years of the major, especially in BC last year, where we had a heat dome, one of our worst wildfire seasons, and then that atmospheric river really suddenly put it on the map that I think our government officials and everybody recognize. For BC, this is not an option. We have to consider these things. So that Climate Preparedness Adaptation Strategy, which is a BC specific thing, is now on everyone's radar. All of our local governments and First Nation communities are now recognize, okay, these are things we just have to do. And it's really good. And the other thing that's actually just changed in here in the last few weeks, we have a emergency management kind of entity in the provincial government. It was always under another ministry. It actually got elevated to its own ministry, and it's now the Emergency Management and Climate Readiness Ministry. And so I think that's also kind of sent out a signal to all of our province that this is very important. Public thinks it's very important, and we're going to start focusing on this. So I think now the biggest next thing will be from the local governments and Indigenous communities, like, okay, this is going to cost us. We need funding. What are the funding mechanisms? And that'll be the next step. Is we want to account for climate, but how do we do that and afford it as a small community that has limited funds? But yes, I think in BC it's very recognized, and I think these events of the last couple of years has just made it, just put it on our radar, and we recognize we need to do that because like some people made in the comments, doing nothing is way more expensive trying to fix these things after the fact. So yeah, I think we're quite progressive on that, and I think we'll start seeing that become requirements and rules and built into our policies.
Great, thank you, Ian, and thank you, everyone. There's a huge amount of brain power represented on this panel here, and we really appreciate your time and your ongoing contributions to the PIEVC community over the decades that you've been involved, and all the case studies that have been presented today set really great examples for future users. So once again, on behalf of the PIEVC Alliance, who are stewarding the program, we really appreciate your ongoing commitment. And we'll, of course, continue to turn to you for advice and guidance as we go forward. So thanks once again. I think we're turning it back to some PowerPoint slides here. Okay, good. So as we mentioned briefly, just in the last couple of minutes here, we do have another PIEVC high-level screening guide webinar coming up on February 9th, and we'll feature 5 more presentations. The presentation will be even tighter in this case. And we may forego questions in this case, just with the interest of getting as many of these case studies out into the public realm as possible. So on February 9th, we'll hear from Quentin Chiatti from Matrix Solutions about use of the high-level screen guide for a climate adaptation plan being prepared by a medium-sized Ontario municipality. We'll hear from Glenn Milner from JLL about potential use in the real estate sector. We'll hear from our colleague from Prince Edward Island about application to wastewater system for a small municipality there. We'll hear about some more of the federal government assessments that are going on, 3 bridges in Ontario from Lindsay Allen at CBCL. And we'll also hear about a new buildings BC guideline for buildings from the BC Climate Action Secretariat. So keep an eye on your inboxes on February 9th. We'll have another session for the high-level screening guide. Aside from that, we will also have another webinar on February 16th. In this case, the webinar will focus on PIEVC Green and will be moderated by our colleagues from GIZ in Germany. And a final reminder also to join the PIEVC Practitioners Network. And I think Claire has provided the link there a couple of times. It's a free network, and we'd like to keep these conversations going there. So feel free to join whenever you have a chance. And just as we wrap up here, I think there will be a link to a survey. So please take the time, a couple of minutes to fill out the survey. We use your responses to help plan future engagement events through the PIEVC program. So we appreciate your input there as well. So I'm going to wrap it up and say thanks very much to Claire Sanders, who's been running all of these webinars on the tech side in organizing much of the background work. So thank you, Claire, and thanks once again to our excellent panelists, and for Ian for joining in at the last minute as well. It was good to see you all, and we'll end it there. And we'll hope to see everybody again on February 9th.
Very good. Thank you very much. Have a great day.